morning, one and all. Myself, Sreevani, working as an assistant professor in the Department of ECE in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in today's lecture, we are going to learn about the relationship between electric fields and the magnetic fields, which are to be given by the equation called electromagnetic wave equation, also called as uniform plane wave equation. So before going to derive the relation between electric field strength E and the magnetic field strength H, we need to know what actually uniform plane wave, then how it is propagating in free space medium. From that, we are going to get the relation between E and H is to be derived. Right? So firstly, according to the definition of uniform plane wave, how we are going to define this uniform plane wave? Means the wave uniform plane wave is the wave that will have variation only in the direction of propagation and its characteristics remains constant across the planes normal to the direction of the propagation. So, according to the definition, means if you are considering the two direction components, means x, y, z or the 3D wave, we are going to analyze the electromagnetic wave or uniform plane wave with a 3D view. So suppose if you are assuming if electric field is in x direction and the magnetic field is in y direction and the wave which is to be propagating in the opposite to that of those two, hence it is the direction of this one is represented with P. Right? So, in order to know the uniform plane waves which is to be propagating in free space, let us see the characteristics of the free space medium. So, for a free space medium, sigma is to be assumed as 0 and epsilon is replaced by epsilon naught and mu is replaced by mu naught. Right? So, in order to derive the relation between electric field strength E and the magnetic field strength H, we are going to see here sigma equal to 0 and epsilon equal to epsilon naught, then mu equal to mu naught. Right? So, uniform plane waves in free space propagation, now we are going to discuss. So, initially, in order to derive the relation between electric field strength E and the magnetic field strength H, we need to know what are the three different characteristics of the uniform plane waves which are to be propagated in the free space medium. So sigma equal to 0, conductivity of the free space medium is equal to 0, and in general epsilon is defined as epsilon naught into epsilon r. For a free space medium, its value equal to 1, hence epsilon is considered to be as epsilon naught. Similarly, for the mu can be given by mu naught into mu r. Now, for a free space medium, mu r is equal to 1, then mu is to be replaced by mu naught. So, uniform plane waves in the free space medium. In order to derive the relation mathematical equation, we just assume an electromagnetic wave which is to be traveling in free space medium. Then consider an electric field is in x direction and the magnetic field is in the y direction. And the wave which is to be propagating in the z direction, we are supposed to assume. So, initially, the electric field is in x direction and the magnetic field is in the y direction, and the wave which is to be propagating in the particular medium is to be considered according to the z direction. So that's why now in order to derive the relation, we need to know what are the two Maxwell's equations which to be used in the time varying fields or electromagnetic fields. So the two Maxwell's equations which are there in the time varying fields as modified form of the Ampere Circuit Law, and it is given by del cross H bar is equal to J plus JD, where J is said to be conduction current density and it is given by sigma into E bar, where JD is said to be displacement current density and it is given by dou D bar by dou T. Right? So first consider the modified form of the Ampere Circuit Law, then another Maxwell's equation for the time varying fields which is to be derived from the Faraday's law as del cross E bar equal to minus dou B bar by dou T. Okay, so first consider here modified form of the Ampere Circuit Law. then del cross h bar equal to j plus dou d bar by dou t. Now for a free space medium, we are assuming it has sigma equal to 0. Hence, here del cross h bar is equal to j plus dou d bar by dou t. Then if j equal to 0. Why if j 0 means according to conduction current density, j equal to sigma into E. Then if we substitute sigma by 0, then j becomes 0, which is to be equal to dou d bar by dou t as obtained. Now d bar can be expressed in terms of Cartesian coordinate system. Variables are given by x, y, z. Hence, dou by dou t of dx ax, dy ay, dz az is to be obtained as del cross h bar is equal to dou d bar by dou t can be written as dou by dou t of vector d can be written in the Cartesian coordinate system or rectangular coordinate system is dx ax plus dy ay plus dz az. Okay, so now substitute in place of d by this vector form, then it is going to get here del cross h bar is equal to, on the RHS, dou d bar by dou t, then d bar can be expressed in terms of Cartesian as the previous one. Now if you consider LHS part, del cross h bar is equal to ax bar, ay bar, az bar. So in order to express this one curl of a magnetic field intensity, we are going to use it in the determinant form. So data of the vector form or matrix forms can be written as, in the first row we are going to consider all the unit vectors of the three directions as ax, ay and az, and the partial derivatives we have considered for the three directions as dou by dou x, dou by dou y and dou by dou z, and the three magnitudes of the h directions as hx, hy, hz are to be considered. Upon expansion of this equation, we are going to get ax bar into dou hz by dou y minus dou hy by dou z minus ay into dou hz by dou x minus dou hx by dou z plus az into dou hy by dou x minus dou hx by dou y can be considered. Now, as we have assumed initially, as electric field is in x direction and the magnetic field is in y direction, and initially from that assumption, as h is in y direction, the other components directions magnitude terms tends to zeros. Hence, hx, hz are tending to 0. So hz is equal to 0, then hz is equal to 0, hx is also 0, hx is also 0. And what are the two terms which are to be left out is given by here, minus ax into dou hy by dou z, the first term, and the last one is minus plus az into dou hy by dou x, which is equal to, in the RHS part, we have here dou d bar by dou t. So d bar can be expressed in terms of Cartesian coordinate system dx ax plus dy ay plus dz az. Now, by comparing means, before going to compare, again we need to consider one more assumption is here, as hy is not changing with x. Hy is not changing with x and it is uniform in the xy plane. Hy is not changing with x means dou hy by dou x term tends to 0, and we are going to have the equation which is to be left out as minus dou hy by dou z into ax equal to dou by dou t of the complete vector d dx ax plus dy ay plus dz az. Now both sides compare vector direction components plus the x components. Why? Because here x component is only left out, hence the ay and az terms tends to zeros, and if you compare both sides, minus dou hy by dou z is equal to dou dx by dou t. Or if you substitute d by epsilon into e, then that equation to be considered dou hy by dou z is equal to minus epsilon into dou ex by dou t. Right? So, consider this as equation number 1. Dou hy by dou z is equal to minus epsilon into dou ex by dou t. Now, from the Faraday's law. So, from the Ampere Circuit Law, we have got one of the relation as the previous one. Now, from Faraday's law, the equation is del cross E bar equal to minus dou B bar by dou t. Now, dou B bar by dou t. So, before expanding this dou B bar by dou t, first consider LHS part, hence it is del cross E bar is equal to. So, how we have written in the case of del cross H bar, curl of magnetic field intensity. Similarly, here also, the curl of electric field intensity can be written as in the vector form as Ax bar, Ay bar, Az bar, dou by dou x, dou by dou y, dou by dou z, and the three magnitudes of the three directions as Ex, Ey, Ez are to be written. Right? So, by expanding this equation, then we are going to get Ax into dou Ez by dou y minus dou Ey by dou z minus Ay into dou Ez by dou x minus dou Ex by dou z plus Az into dou Ey by dou x minus dou Ex by dou y. Right? So, as we have assumed initially as electric field is in x direction and the magnetic field is in y direction. So, now we are analyzing electric field equation. Hence, as E is in the x direction, y components tending to 0. Y and z components are tend to 0. So, Ey equal to Ez equal to 0. So, the components which are there in the Ey along with the Ez are tends to 0 upon expansion of this del cross E bar. Hence, Ez, Ey, 0, 0, Ez also 0, then Ey also 0. So, the two terms which are to be left out is here minus of minus becomes plus Ay into dou Ex by dou z, then minus Az into dou Ex by dou y. Right? So, these are the two components which is equal to minus dou by dou t into b. So, that b is expressed as bx ax plus by ay plus bz az, which are to be in the Cartesian coordinate system vector form of magnetic flux density. So, minus dou by dou t of bx ax plus by ay plus bz az are to be obtained. Now, according to that, another assumption is Ex is not changing with y. So, previously we are assuming Hz is not changing with x. So, herely Ex is not changing with y means dou Ex by dou y terms tends to 0 and it is uniform in the xy plane. Xy plane means z is equal to 0 plane we are going to consider. Right? So, now dou Ex by dou z is equal to minus dou By by dou t, or if you substitute b by mu into h, then it becomes dou Ex by dou z is equal to minus mu into dou hy by dou t. Okay? Or dou hy by dou t equal to minus 1 by mu into dou Ex by dou z. So, that we are going to consider it as equation number 2. And from equation number 1 means that is dou hy by dou z is equal to minus epsilon into dou Ex by dou t. This is the equation number 1 which is obtained from the modified form of the Ampere Circuit Law. And from equation number 2, how this equation number 2 is to be obtained means from the Faraday's experiments or Faraday's law, dou hy by dou t equal to minus 1 by mu into dou Ex by dou z. Right? So, in order to simplify the uniform plane wave equation or electromagnetic wave equation, we are going to consider equation number 1 and 2 by equating either LHS parts or RHS parts must be equal to same. So in order to simplify that one, first consider equation number 1. This equation, dou hy by dou z is equal to minus epsilon into dou ex by dou t. And consider that equation differentiating equation number 1 with respect to t. So already it is differentiating with respect to z. Again we are going to differentiate that equation with respect to t. Then differentiation variables need to be changed. Hence dou by dou t of dou hy by dou z is equal to. So if you apply here differentiation on both sides, dou by dou t of dou hy by dou z is equal to minus epsilon into dou by dou t of dou ex by dou t. So dou by dou t and again dou by dou t. Hence it becomes dou square ex by dou t square, which is equal to dou by dou t of dou hy by dou z. Now consider this as another equation. Let it be equation number 3. Now consider equation number 2. So this equation dou hy by dou t equal to minus 1 by mu into dou ex by dou z. Now differentiate equation number 2 with respect to z. So consider equation number 2. Now differentiate that one with respect to the z. Then LHS part of number 2 becomes dou by dou z of dou hy by dou t equal to minus 1 by mu into dou square ex by dou z square. Right? So already dou by dou z of dou hy by dou t equal to minus 1 by mu into dou by dou z of dou ex by dou z. Then it becomes minus 1 by mu dou by dou z of again dou by dou z of, hence it becomes dou square by dou z square of ex. Right? So consider this as equation number 4. Now if you compare equation number 3 with number 4, LHS parts of 3 and 4 must be same. So if LHS part of 3 and 4 are same means RHS part of 3 and 4 must also be same. So if you compare like that, minus epsilon dou square ex by dou t square equal to minus 1 by mu dou square ex by dou z square. Right? So both sides this negative gets cancelled. Dou square ex by dou t square equal to 1 by mu epsilon into dou square ex by dou z square. So this is called the uniform plane wave equation or electromagnetic wave equation. Right? So dou square ex by dou t square, which is equal to, so this 1 by mu epsilon is replaced by complete term is replaced by here v square. Why? Because v is nothing but 1 by root of mu epsilon. Velocity of the wave in free space medium is given by v equal to 1 by root of mu epsilon and its value is given by 3 into 10 power 8 meters per second. How this value is to be obtained means, as we know that for a free space medium, epsilon is nothing but epsilon naught and mu is nothing but mu naught. Right? So if you substitute epsilon naught and mu naught by epsilon naught value as equal to 8.854 into 10 power minus 12 farad per meter and mu naught value is 4 pi into 10 power minus 7 Henry per meter. Now if you substitute these two in this equation, 1 by root of mu epsilon means 8.854 into 10 power minus 12 into 4 pi into 10 power minus 7 Henry per meter. If you multiply these two, we are going to get its value as approximately 2.99 into 10 power 8 meters per second, or it is approximately equal to 3 into 10 power 8 meters per second. Right? So this is the way velocity of a wave, electromagnetic wave in free space medium value is to be obtained as 3 into 10 power 8 meters per second. Right? So this is the wave equation. Dou square ex by dou t square equal to v square into dou square ex by dou z square is called as uniform plane wave equation or electromagnetic wave equation. Or we can write this equation as like this also. Dou square ex by dou t square minus v square into dou square ex by dou z square equal to 0. Right? So either of the equations for representing the uniform plane wave equation or electromagnetic wave equations. Right? If you observe, this one is the second order differential equation. If you simplify this equation, means that equation to be dou square ex by dou t square minus v square into dou square ex by dou z square equal to 0. Right? Dou square ex by dou t square minus v square into dou square ex by dou z square is equal to 0 is called as electromagnetic wave equation. Electromagnetic wave equation or uniform plane wave equation. So if you observe this one, it is a second order differential equation, right? So if you simplify this equation, the solution may be obtained as Ex is equal to Em plus into cos of omega t minus beta z plus Em minus into cos of omega t plus beta z. Right? So here if you observe, it consisting of the electric, initially we are assuming the uniform plane waves definition. According to that, electric field is in x direction and the magnetic field is in the y direction. So Ex is equal to, after simplifying the second order differential equation, Ex is to be obtained as Em plus cos omega t minus beta z plus Em minus into cos omega t plus beta z. Means basically this equation consisting of two traveling waves. One is traveling towards forward direction and one more is traveling towards the backward direction. So one is representing positive component, another one will be the negative component. So where Em plus and Em minus are representing the magnitude of the forward traveling wave as well as the backward traveling wave components, where omega be the angular frequency of the wave and the t be the always independent variable, beta be the phase constant and z direction is the wave propagation direction. Right? So Ex is equal to, this is the equation which we have got. Now previously from the evaluation of that equation, dou Ex by dou z is equal to minus mu into dou Hy by dou t, or dou Hy by dou t equal to dou Hy by dou t equal to minus 1 by mu into dou Ex by, consider this as the one relation, dou Hy by dou t equal to dou Hy by dou t equal to minus 1 by mu into dou Ex by dou z. Okay, so consider this equation. Now if we substitute Ex by this equation in this, then we are going to get minus 1 by mu into dou by dou z of Ex, means Em plus cos omega t minus beta z plus dou by dou z of Em minus cos omega t plus beta z. Right? So minus 1 by mu Em plus, if you take here as common, then dou by dou z of differentiation of cos function becomes minus sin omega t minus beta z into minus beta then here it will be minus 1 by mu Em minus into differentiation of this function becomes sin omega t plus beta z into beta. Okay, now if you simplify this one, then it becomes minus Em plus, so minus of minus plus and here also minus, then minus Em plus beta by mu into sin omega t minus beta z, then minus Em minus by mu into beta sine omega t plus beta z. So dou hy by dou t is equal to, this is the way we are going to get the equation. Now we have to simplify the equation for hy. Again consider both sides integration. Right? To get the equation for hy component, we are going to apply both sides integration. Then hy component becomes, hy means integration of this component minus em plus beta by mu, then integration of sine omega t minus beta z into dt minus em minus beta by mu integral sine omega t plus beta z into dt. So if you simplify this equation, we are going to get hy is equal to hm plus cos omega t minus beta z minus hm minus cos omega t minus plus beta z is to be obtained, where hm plus and hm minus are the two magnitudes of the forward traveling wave as well as the backward direction of the uniform plane wave components. So Ex component is to be obtained as Em plus cos omega t minus beta z plus Em minus cos omega t plus beta z. Similarly, in order to get this Hy component, Hm plus cos omega t minus beta z minus Hm minus cos omega t plus beta z. Right? So these are the two solutions for the second order differential equation if we solve that electromagnetic wave or uniform plane wave equation. Right? So after that, from that of the propagation of the wave, which is to be in free space medium, when any wave is propagating into the particular medium, it gets attenuated. Sometimes some phase changes may also arise. Sometimes the propagation constant term is also to be varied. So based upon that, some of the constants can be defined as attenuation constant as denoted with alpha. How this attenuation constant alpha is to be defined means when any wave propagates into the medium, it gets attenuated. Means attenuation means the amplitude of the wave is to be reduced. Right? So strength of the wave is to be reduced. The amplitude of the signal is reduces and it is represented by attenuation constant alpha and it is measured in the Nepper per meter. Sometimes this alpha is also to be measured in the decibels. There is a relation between the Neppers and the decibels and its value is given by 1 Nepper is equal to 8.686 decibels. Right? When any wave propagating into the medium, it gets some attenuation. Means amplitude of the wave is to be reduced. That constant is denoted with attenuation constant and it is represented with alpha. Then sometimes it is measured Nepper per meter and sometimes it might be with decibels. That's why there is a relation between Nepper and decibels are given by 1 Nepper equal to 8.686 decibels. Right? Next, along with the attenuation, along with the signal reduction, sometimes the phase changes may also take place. Such phase constant is represented with phase constant as beta and it is measured in radians per meter. So phase constant beta is represented as here. When any wave propagates into the medium, phase changes may also take place. Such a phase change is expressed by a phase constant as beta and it is measured in radians per meter. Attenuation constant alpha is to be measured in the Nepper per meter, whereas phase constant is measured as in the radians per meter. Next is, along with the attenuation constant alpha and the phase constant beta, we also get another constant called propagation constant, which constitutes both the attenuation constant alpha and the phase constant beta. Hence, the attenuation constant alpha and the phase constant beta together constitutes a propagation constant gamma. And it is given by gamma equal to alpha plus j beta. alpha be the attenuation constant and beta be the phase constant, and where gamma is given by here propagation constant, and it is measured in meter inverse or per unit length, hence it is 1 by meter is the unit for the propagation constant. Next, along with these three constants alpha, beta, and gamma, we also have another component called intrinsic impedance. So notation is given by here eta. So intrinsic impedance is denoted with eta, and it is the ratio of, means how we are going to define this intrinsic impedance, means ratio of amplitudes of the E to H, electric field strength E to the magnetic field strength H of the waves in either of the directions, means either positive direction or the negative direction, is called as the intrinsic impedance of the material in which the wave is traveling. So in order to derive the condition for that is eta equal to. So generally impedance means it is a complex form of the resistance, and it is given by impedance Z is equal to V by I. So in the similar way here also intrinsic impedance, hence all the terms are related to V is replaced by here E and I terms are replaced by H. Suppose if we are considering all the forward wave traveling, then two magnitudes are representing here EM plus and HM plus, right? So eta equal to EM plus by HM plus. Now eta equal to EM plus by HM plus or EM minus by means minus of EM minus by HM minus, right? So if you substitute all these terms EM minus by HM minus or EM plus by HM plus, then the two terms are to be obtained as omega into mu by velocity, right? So here omega by beta is sometimes defined with the velocity as omega by beta. Velocity V equal to omega by beta. So the relation is given by here V into root of mu. So where this V is given by velocity of the wave, which is in the free space medium 1 by root of mu epsilon. And if you substitute velocity by here omega by beta, then these two are given by here eta equal to V into mu, or sometimes how this has to be obtained means V equal to 1 by root of mu epsilon and mu. So eta equal to velocity into mu. If you substitute velocity by that one 1 by root of mu epsilon into mu, then it becomes mu square by mu epsilon under root. So mu square and mu gets cancelled, which is to be obtained as mu by epsilon, right? So eta equal to root of mu by epsilon. So now we are discussing all these components are related to the free space medium. Hence for a free space medium, these two values are mu naught and epsilon naught, right? So eta naught means intrinsic impedance of the wave which is in free space medium is to be obtained as eta naught, which is equal to root of mu naught by epsilon naught, right? As we know that mu naught value is 4 pi into 10 power minus 7 by epsilon naught value as 8.854 into 10 power minus 12, then if you find this one, it is approximately equal to 377 ohms or 120 into pi ohms. Eta naught. Impedance, no, generally it is measured in ohms and its value is to be obtained as 120 into pi or 377 ohms, right? So for a free space medium, velocity is given by V equal to 3 into 10 power 8 meters per second, and intrinsic impedance of the free space medium eta naught is given by here 120 into pi ohms or 377 ohms, right? So this is the way the waves or the terms which are to be defined for a free space medium, the wave which is to be propagating in free space medium, right? So now from the uniform plane wave equation or from the electromagnetic wave equation, now we are going to see here uniform plane waves in phasor form. How these uniform plane wave is to be represented in the phasor function, phasor form. Hence, so in order to derive the relation, we are going to use here from the Faraday's law. So as we know that del cross E bar equal to minus dou B bar by dou T. So from the Faraday's experiments, del cross E bar equal to minus dou B bar by dou T, and if we substitute B by mu into H, then minus mu into dou H bar by dou T. Consider this as equation number 1. Now to simplify that one, uniform plane waves in the phasor form, we need to apply both sides of this equation with the curl function. Means both sides, if we take curl on, then equation number 1, then del cross E. Already curl of a vector electric field intensity E we have considered according to the Faraday's law. Again, in order to simplify that one in the phasor form, we are taking curl on both sides of this equation number 1. Hence, del cross E bar equal to minus mu into del cross dou H bar by dou T. Or simply we can write this one as minus mu into dou by dou T of del cross H bar. Del cross dou H bar by dou T can be written as here dou by dou T of del cross H bar. Right? So, now to simplify this one, again, we are going to consider here one of the vector identity as del of del dot E. Del of del dot E minus del square E equal to, means this del cross E can be written according to the vector identity is del of del dot E minus del square E. Del of means gradient of del dot E bar, divergence of electric field intensity, minus del square E is for Laplace's law, Laplace's equation. So del cross E bar can be given in the vector identity as del of del dot E minus del square E, right? So upon expanding this equation, then is minus mu into dou by dou T of del cross H bar. So from this equation, by according to the vector identity, these two are written as del of del dot E minus del square E, which is equal to minus mu into dou by dou T of del cross H bar. Okay, so from this, consider this is the one of the relation, and one more time varying field equation, that is to be modified form of the Ampere's circuit law, that is del cross H bar equal to J plus dou D bar by dou T. Right? So from this, we are going to have here del cross H bar equal to J plus dou D bar by dou T. Then if we substitute in place of del cross H bar, then this equation is written as here del of del dot E minus del square E equal to minus mu into dou by dou T of J plus dou D bar by dou T. Right? So that according to the modified form of the Ampere circuit law, we know that equation del cross H bar equal to J plus JD bar, where J is sigma into E plus JD is given by dou D bar by dou T. Right? Conduction current density by including displacement current density, that equation to be written as del cross H bar equal to sigma into E plus dou D bar by dou T. Okay. Now, minus del means here we have del of del dot E minus del square E is there in the LHS part of that equation. Here del dot E equal to 0. Why del dot E equal to 0? Means for a static fields E equal to 0. Sigma equal to 0, and sigma 0 means E is also 0. Hence, del dot E bar equal to 0 for the static fields. Now, inside this one, del of del dot E becomes 0 according to the static fields. Then, minus del square E equal to minus mu into dou by dou T of J plus dou D bar by dou T. Right? Both sides this negative gets cancelled. Then del square E equal to mu into dou by dou T of plus J plus dou d bar by dou t. Right? When any field varies with respect to the time, then its partial derivative taken with respect to the time can be replaced by j omega. Means dou by dou t is replaced by j omega. Right? So in which positions dou by dou t is exist, in that we just replace by j omega and all. Then this equation number 5 becomes del square E equal to mu into j omega mu. Now from this, del square E equal to mu into dou by dou t is replaced by j omega plus j into j plus dou by dou t, means j omega d bar. Okay, then if you simplify this one, j omega mu plus j into, means actually where j is said to be conduction current density and it is given by j equal to sigma into E. So j omega mu into sigma into E. Now if you simplify this equation, mu into j omega plus j means sigma into E plus j omega d is nothing but epsilon into E. Right? So if you simplify this equation, then we are going to get j omega mu into sigma plus j omega epsilon into E. So out of these two, between these two, if you substitute j by sigma into E, d by epsilon into E, E is common between two. Hence, j omega mu into sigma plus j omega epsilon into E is to be obtained from the previous analysis. Del square E equal to j omega mu into sigma plus j omega epsilon. And similarly, so if you are considering or if you are evaluating the equation with respect to E, then we are going to get that one as del square E equal to j omega mu into sigma plus j omega epsilon into E, or similarly del square h bar equal to del square h bar equal to j omega mu into sigma plus j omega epsilon into h. Now from these two, we are going to get here del square E bar equal to gamma square into E bar, or del square E bar minus gamma square E bar equal to 0. And from this equation, del square h bar equal to gamma square into h bar, or del square h bar minus gamma square h bar equal to 0. So collectively we can write these two equations, means del square E bar minus gamma square E bar equal to 0 and del square h bar minus gamma square h bar equal to 0 are collectively known as Helmholtz equations. Important one we need to remember. So what are the Helmholtz equations? Means the phasor form of uniform plane wave equations are called as Helmholtz equations, and these two are del square E bar minus gamma square E bar equal to 0, then del square h bar minus gamma square h bar equal to 0. Or from this, gamma or propagation constant of that uniform plane wave can be obtained as under root of j omega mu into sigma plus j omega epsilon. Right? So the wave characteristics means we are supposed to consider sigma, omega, then epsilon and mu. Conductivity of the medium and angular frequency of the wave and permeability of the medium along with the permittivity of the medium. How the wave is to be characterized means depending upon the conductivity, depending upon the permittivity, depending upon the permeability, these are the wave characteristics are to be defined. Right? So Helmholtz equations are obtained from the phasor form of the uniform plane wave equations as del square E bar minus gamma square E bar equal to 0, or del square h bar minus gamma square h bar equal to 0. Then del square E bar equal to gamma square E bar and del square h bar equal to gamma square h bar are called as Helmholtz equations. Right? Now if you simplify, means previously we have got the gamma, propagation constant gamma can be written as here j omega mu into sigma plus j omega epsilon under root of. right? So, and previous analysis, according to the constants we have considered for the propagation of the wave, which is in free space medium, as gamma equal to, it constitutes both the attenuation constant alpha and the phase constant beta, then gamma equal to alpha plus j beta, which is equal to under root of j omega mu into sigma plus j omega epsilon, right? So, from this analysis, if you separate the real term as alpha, nothing but attenuation constant, and it is to be obtained as omega root over mu epsilon by 2 under root of 1 plus sigma by omega epsilon whole square minus 1. And for the phase constant beta is to be given by beta equal to omega root over mu epsilon by 2 under root of 1 plus sigma by omega epsilon whole square plus 1. And similarly, intrinsic impedance eta, we know that eta equal to, it is the ratio of the electric field strength to the magnetic field strength. Then from that, we are going to have here under root of j omega mu by sigma plus j omega epsilon, right? So these are the different characteristics which are to be analyzed for the uniform plane wave, which is to be propagating in free space medium, right? So in this lecture, what we have learned is definition of a uniform plane wave. Now, the wave which is to be uniform plane wave or electromagnetic wave, which is to be propagating in free space medium. In order to derive the mathematical equation for the uniform plane wave equation, we need to know what are the fundamental characteristics of the free space medium and all we have learned. For a free space medium, sigma equal to 0, epsilon equal to epsilon naught and mu equal to mu naught. Depending upon all this, and we have used two Maxwell's equations. One is del cross h bar equal to J plus JD, and another Maxwell's equation is from the Faraday's law, del cross E bar equal to minus dou B bar by dou T. These are the two Maxwell's equations which we have used. Then from that we have got electromagnetic wave equation or uniform plane wave equation. Now from that uniform plane wave equation, we have got three constants as attenuation constant alpha, phase constant beta, and the propagation constant gamma. Along with these three constants, we are also learned about one of the parameter called intrinsic impedance, and it is the ratio of the electric field strength E to the magnetic field strength E. And we have also learned in this lecture as the uniform plane waves in the phasor form equations are to be known as Helmholtz equations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.